Bismillahirrahmanirrahim. Kita sambung dengan chapter 2 ya. Molecular Absorption, Spectroscopy, Theory, Instrumentation and Application. For outline of this topic, we will cover this one first. 2.1 up to 2.1.5, some sample container, which is under components of instrument for optical spectroscopy. If you look at this picture, this shows a basic component of the optical spectroscopy. So normally we will have a radiation source or lamp. So we have in UV we have two lamps. One is for UV, one is for visible. Then we have wavelength selector, or we call it monochromator, and we have a detector, and we have data processor, transducer, and data processor. This is read out. Okay, this is the 5 basic optical instrument component. The first one, we must have sources. Source must be a stable source of radiant energy at desired wavelength or lambda, or lambda range. The second one, we must have sample container. Sample container must be a transparent container to hold the sample. Normally we call it cell or cuvette. Wavelength selector is a device that isolates a restricted region of the electromagnetic spectrum used for measurement. Either monochromator, prism and filter. These three is the types of wavelength selector. The fourth one is the detector or photoelectric transducer. Because we deal with the photon, so we call it photoelectric transducer. Transducer means that detector that can convert a signal. It must convert the radiant energy into usable signal, normally in the form of electrical signal. And the last one is the signal processor and readout that display the transduced signal on the meter scale, a computer screen, a digital meter, cathode ray tube, LCD panel or another recording device. So this is 5 basic components of optical instrument. Okay. This is another diagram showing general design of a basic component of optical instrument. If you look at this one, this is in absorption spectroscopy. If the instrument measure absorption, this is emission spectroscopy when the instrument measure emission. If you still remember interaction of electromagnetic radiation with the sample, kan ada banyak jenis in refraction, transmission, absorption. So if you look at these two, the difference between absorption and emission, if in absorption you must have radiation source, then this is our sample. In emission spectroscopy, the radiation source and sample is placed together, because we record emission. The substance need to be excited first. At excitation stage, we don't measure anything, but when it go back to lower energy level, emit radiation, then that emission will be recorded. In absorption, we provide radiation, sample absorb. Absorption process is already measured, but in this one, emission process, then baru dia measure. Then normal, same, we have wavelength selector, detector and data processor or readout. Okay, now we look at detail of each component. The first one is the source of radiation. The source of radiation must be able to generate a beam of radiation that is stable and has sufficient power. Okay, for example, kalau saya nak explain yang senang untuk instrumen ni dia tak boleh lah macam lampu kita yang dah malap dah lama. Kalau kamu tengok lampu kat rumah tu kan, kalau mentor tu dah lama dia akan malap sikit. Okay, means that dia punya power dah kurang dah. Okay, ada pula lampu yang macam klip-klip macam tu means that it is not very stable. So lamp in this instrument must be stable and has sufficient power. Dia memang kita kena record. Oh, lampu ni dah guna berapa lama, at certain period memang dah tak boleh guna. Kalau kita guna, result dia tak boleh tak boleh tak accurate. Okay, memang kita kena tukar lah. Sebab tu biasa instrumen dia akan record dah berapa lama dah lampu tu digunakan, berapa jam dah ataupun berapa kali eksperimen. Okay, so we have two types of radiation source. The first one is continuous source, and the second one is line source. Okay, continuous source emit radiation over a broad wavelength range, and the intensity of the radiation changes slowly as a function of wavelength. This type of source is commonly used in UV, visible and IR instrument. So continuous source is normally used in UV spectroscopy, visible ataupun UV visible spectroscopy and infrared spectroscopy. Okay, this is the types of continuous source. Ni nama-nama lamp dia lah. We have deuterium lamp, tungsten filament lamp, glowing inert solid. So each one ni you must remember. This is used for what? For this one, deuterium is used in UV to provide UV radiation. Deuterium is to provide UV radiation. Tungsten filament lamp is to provide visible radiation. Glowing inert solid is used to provide infrared radiation. So deuterium is used for UV. Tungsten and filament is used for visible. Glowing inert solid is used for IR. Kalau kita tengok yang mula-mula tadi, deuterium and tungsten ni dia letakkan dalam satu instrumen because normally UV and visible spectroscopy instrument, one instrument can be used to analyze in these two regions, in UV region and in the visible region. So that's why we call it UV visible, UV vis spectroscopy, because it covers in both regions. The second one is line source. Line source. From the names, if we still remember, line spectra and continuous spectra. Continuous tu semua ada radiation lah, semua wavelength ada radiation. Kalau line spectra, at certain wavelength je dia ada radiation. So the same is the continuous source dengan line source. A line source emit a limited number line or band of radiation at specific wavelength. Normally it is used in atomic absorption spectroscopy and molecular fluorescence spectroscopy and Raman spectroscopy. This source usually provide radiation in the UV and visible region of electromagnetic spectrum. This is types of line source. We have mercury and sodium vapor lamp, which is used in UV visible instrument, and we have hollow cathode lamp and electrodeless discharge lamp, which is used in atomic absorption and fluorescence spectroscopy instrument. Okay, so that is line source. Means that line source ni dia provide radiation at certain wavelength only. Okay, if you still remember, and another types of line source. Yeah, another example, another types of line source lamp is laser source. Yeah, laser is actually a short name for light amplification by stimulated emission of radiation. This lamp, this lamp is used in Raman spectroscopy for molecular absorption analysis. Emission spectroscopy and as a part of instrument for Fourier transform infrared spectroscopy. This laser source produce specially narrow, very narrow band up to few hundred micrometer with high intensity of beam and high monochromatic beam. Okay. Okay, so this picture show hollow cathode lamp. Yeah, this is the name of the lamp which can provide line source. Yeah, the name is hollow cathode lamp. It's got name hollow cathodes because dia punya cathode ni, yang ini dalam ni tengah-tengah ni dia kosong je. That's why we call it hollow cathode lamp. Kalau kamu tengok ni, dia macam lampu mentol lah kan, cuma bentuknya lah macam silinder kan. Sama je lah, cumanya yang specialnya dia adalah dalamnya ada gas ya, at very high pressure. So dia punya material ni is made up of what material yang kita interested. Hollow cathode lamp ni dia ada banyak, ada sodium, ikut elemen. Semua elemen yang kita nak analyze tu ada lamp dia sendiri. Okay, so this is lamp. Yang ni lampu banyak-banyak tu dia masukkan dekat port dalam instrumen tu. Okay, this is electrodeless discharge lamp. Sama, HCl hollow cathode lamp and electrodeless discharge lamp is used for atomic absorption spectroscopy. Dia lampu dia samalah macam mentol. Kalau kamu pernah tengok mentol apa ni kan, dalam kat kereta ke apa ke, mentol dia macam ni lah. Cuma dia letakkan casing dekat hujung kat sini untuk radiation to pass through. Okay, memang casing dia berbeza lah sikit sebab lampu ni biasanya mahal. Nak jaga dia punya durability bagi tahan lama, diletakkan casing dia yang sedikit tough lah, because dia punya material ni macam very fragile. Boleh pegang tak kena sikit boleh patah. Okay, the price can be up to 1,000 ringgit setiap satu, 1,000 lebih lah. Okay, and the last for this recording video, this is the material. A table to show what region of spectroscopy and dia punya radiation source. Yeah, for example, vacuum region, kita gunakan argon lamp. UV and visible, kita guna xenon deuterium lamp. Okay, UV masuk visible sikit, deuterium yang glamournya is deuterium. Kalau visible region, we use tungsten lamp. This is all continuous ya. Untuk near IR, kita gunakan nurse blower. Untuk IR region, we use nichrome wire ataupun global lamp ya. Untuk line source is in the UV and visible region. We have two types of lamp, three types. Hollow cathode lamp, electrodeless discharge lamp, and also laser. Okay. Then we finish with the radiation source. Nanti kita akan sambung with sample container.